most of the crowd has arrived, so let's start the final panel today. Here it's AI and open source versus 6G standardization and regulation. Can there be chaos in the order? Is it necessarily chaos? We will see. As many of you have heard, AI has been mentioned almost in every room. You couldn't go into a session or a keynote or a panel. AI has been all over the place. And there has been a lot of discussions. And in this session, I hope we can get a little bit closer to the physical layer and closer to the wireless interfaces and so on, something that hasn't been entirely discussed in detail, but it has been discussed a lot on a higher level. And for this, we have a panel with a rather wide competence. I'm Ove Edfors, moderator from Lund University. I'm professor of radio systems and work mostly with the physical layer myself and implementation of physical layer. We have Erik Dahlman from Ericsson Research. He knows everything about 3GPP standardization. We have Daniel Verenzuela from Sony Europe, who is engaged in the Wi-Fi standardization, so we have that perspective as well. Then we have Sofie Pollin from Leuven, representing open source software-defined radios and everything. We have Amir Aminifar from Lund University, representing artificial intelligence. And we have Emine, Ozge, Yildirim from Leuven, representing law and, I call it, societal aspects. I hope that's a good description. So, and the questions that we were addressing here is, should the future wireless standards for the next generation follow the conventional standardization approach? Or should we change something? Is there more room for some chaos? There's a lot of things happening on, maybe mostly in the AI arena. New things come out all the time. How do we harness that? How do we use it in the best possible way? And also, open source is a potential way of doing that, because open source allows a quicker development cycle than many traditional methods. So, which role do we see for AI in these wireless standards? And the question that everyone asks, is it opening Pandora's box? There's a lot of discussion about AI in general. Is it gonna take over humanity? I think we're talking a little bit smaller scale here. Is it a Pandora's box for the communication society? We don't have to include everything here, but and looking at it from all the way to, from processing signals and so on, to more using AI to maybe drive standards, have ideas for things in standards and so on. And we have also heard previous this morning that we should be more flexible when it comes to air interfaces and so on. Physical layer, we should have more flexibility. Can we allow for that with more open source, software-defined radios and so on? Can we be more flexible in terms of standards there? And is this open source, is it something that is absolutely great for new entrepreneurs, creating new concept for communication and so on? And is that a great thing? Or is it a threat to the traditional communications industry, who are used to be following very strict procedures for certification and so on? Or, well, it could be both. It doesn't have to be any of them. And could pushing this open source and AI really far as we can? how can that benefit the users? What are the upsides here? I don't mind if we talk about the downsides also, but it's interesting to see what we can do. So these are basically the 4 questions that the panelists will address in a general sense in their individual presentations. They will also give a short presentation on themselves. I just did a bit of rough statistics here from the proceedings. I downloaded the PDF files, and this is not the high-level science. It's just counting the times words have appeared in all the PDF files. So there were 150 PDF files with papers and some posters. And open source is mentioned 67 times in 20 papers. AI is mentioned 487 times in 16 papers. Standards or standardization is mentioned 147 times in 32 papers, and regulation 42 times in 12 papers. And AI is the clear winner. I mean, it's not even a competition. And that's the impression you also have gotten by listening to talks at this conference. AI pops up everywhere. I think there's also a little bit of AI. It's really simple to write. It's only 2 characters, so you may use it more often. But it's quite clear. AI is very much at the center here at EuCNC. So, with that, I would like to invite the first panelist, Erik Dahlman, to give his view on these questions.
Okay, thank you, Ove. I'm Erik Dahlman. As Ove said, I have been heavily involved in 3D paper standardization for 20 years. So I'm somewhat partial in this topic. But that means I love it or hate it, that's another thing. Your first question was about 6G and Wi-Fi, but I will see it from a 6G point of view. If you follow the conventional standardization approach, should there be room for more chaos in the order? I think the picture hints that I prefer order. Having no rules is probably good if you're kind of traveling alone on a car in the outback of Australia, but as soon as you have a lot of traffic, you definitely need order. But I guess this was not really, the key thing here was probably not the order versus chaos. It was more like we should follow the conventional standardization approach. And actually that's, I think one should be wrong. I think one should be open to, how to say, not just do exactly the same thing as one did before. One should probably do that in every generation. In some sense, unfortunately, I wouldn't say unfortunately, I would say, fact is that most likely 3D PP will follow very much the same approach as it had done earlier. And the reason I can say that is that in essence the approach is already decided on. 3D PP has already, they're already kind of started, both the 3D PP and ITU, they have started on the path to 6G. We have outlined time plans. We know what to do. And it looks very much as we did before. Then people say, I mean, well, they say that 3D PP is a very old organization, too big, is the wrong path. And that may very well be so, but if you look at, I mean, it's in some sense if it's so bad, I mean, more and more, why is everyone joining it? I remember when 2003, there were like 35 companies in 3D PP, and all of those were the kind of old wireless companies. Ericsson, Motorola, Leuven, Nokia, etc., and all the operators. 10 years later, there were 85 companies. Last year, there were 200 companies in 3D PP, a very small minority of them being this kind of traditional wireless companies. It's Amazon, it's car industry, etc., etc. So, clearly, I mean, people are still believing in some way that 3D PP will be successful also in the future. This success has in some sense come with a lot of somewhat problems, which I think it's also a kind of big danger. Right? I mean, that we used to be kind of 2003, there were 100 people at the meeting. 2013, there were 300 people at the meeting. Today, there are more than 1,000 people at a single meeting. We used to have, in round one where I work, physical AI, there used to be like 1,000, a little bit more than 1,000 papers in a year. Today, there are 12,000 input papers per year. So if we don't need any, if we don't use AI for anything else for wireless, I guess we definitely need AI to kind of try to figure out what's in all the papers. So that's, I mean, I think 3D people will most likely follow more or less the same procedure as earlier. We should probably be a little bit kind of vary it a little bit. The other question, what role do you see for AI in wireless systems? And I think it's quite clear. I mean, AI show fantastic results during the last years. Although it's not always fantastic. I actually run a test of myself, who is Erik Dahlman, and I got the answer that Erik Dahlman took a PhD at Chalmers University in 2000. That was wrong. Erik Dahlman has worked at Ericsson Research, which is correct. Erik Dahlman is currently professor in communication technology at Lund Technical University, which you're not very fond of, because that's your job. Actually, my colleague that sits next to me at Ericsson, he got exactly the same answer, so he's also professor at Lund. But I mean, clearly, I mean, there already is AI into a different piece of equipment. Do I believe that AI will in some way replace standardization? I doubt that. But I think, especially, I mean, there is a lot. If you see, people talk about AI and talk about native AI, etc., and it's somewhat unclear exactly what I mean by it. But so such an enormous amount of different things. I mean, we can have AI, of course, within our systems, either within the standards or just within the technology. But we can also, of course, use AI when we are developing the technology, developing the standards. I mean, I've seen people say, okay, I run an AI algorithm, I come up with a new waveform, and then I put that in the waveform explicitly to the standard. And I mean, that's not different compared to like 10 years ago, we decided on certain sequences for 4G or 5G, and we derived them based on computer search. Then we can think about what functions. Is it physical layer functions? Is it higher layer functions? Is it the radio network management? Is it for deployment? My personal feeling, I may be wrong here, is that AI will play a bigger role and give better benefits, how the further up we go into radio network management, scheduling, deployments, etc., compared to the physical layer functions. To me, AI is I expect AI to be more beneficial in cases where we, anyway, today, rely on our gut feelings, compared to if we have kind of a good model of the system, we know what we want to achieve, and the model is not only good, it's also so simple, so we can actually derive something which is close to optimal. I mean, AI cannot do much better than that. But if we go to kind of how we deploy our networks, if we go to how we have radio management, radio resource management functions, etc., we are kind of already today just relying on our gut feelings. And there, I have a feeling could be bigger kind of benefits. Then the question, is it offline training or is it online training? I mean, if it's offline training, we just train, and then we put the kind of ready model into our system and run inference on it. That's just a way of doing essentially nonlinear signal processing. And then I think what we find out, because we're already doing this in 3D people, I mean, one key thing is it kind of one-sided models or is it distributed models? If it's one-sided models, I mean, it's in most cases, very much just an implementation issue. The problems start to get if you have these kind of distributed models that are kind of distributed between network and devices, for example. We need to specify things. Then we are starting to specify how you implement things, and that is something we typically do not want to do. And then this third question, because I think I had partly answered the fourth question already. I mean, AI will be an important technology, and of course, I mean, to enhance the performance of networks, and of course, if it enhances the performance of networks, of course, it will be an end-user benefit as well. The final question, open source opportunity or threat. I'm not sure I really have much to say about it because I'm not all that expert on open source. I don't think we see it Definitely not as a threat. It's probably a good thing to have in some cases, but once again, like AI can mean a lot of different things. There you can today build get an open source the open source code for an entire LTE system. Is that a threat to us? No, obviously I don't think so, because I have doubted an operator that kind of have paid billions of dollars for spectrum would go out and find an open source base station instead of getting a, how to say, state-of-the-art base station. So I don't see open source as a threat. It may be an opportunity in certain cases, but at least for us at Ericsson, I mean, we don't see it as kind of, it's not, at least in the wireless side, it's not kind of a big thing for us. So I think that was what I said. Thank you.
Thank you, Erik. So the next presenter is
So hello everyone, good morning. So my name is Verenzuela, as Ozge said. Thank you for the introduction. And I'm working in 802.11 standards, which is the baseline for Wi-Fi. So before going into the provocative questions of the panel, I think it would be a good idea to talk a little bit about 802.11, because it's not the main part of this venue. So first that we need to think about 802.11 is why is it so let's say, popular, why is it so big? And I think there are three fundamental components of it. On the one side, it's one of the most used wireless communication technologies. Over 50% of IP traffic actually flows to 802.11 wireless LAN networks. Then it's also widespread all over the world. So we're talking about more than 20 billion devices already in use worldwide. And it uses unlicensed spectrum, which means it's free and means everybody can use it. So I think these are three fundamental pillars that makes it so successful in such a powerful technology. Now, if you look a little bit about the evolution of wireless LAN, 802.11 networks, then I think first there was a big thrive to increase the data rates, and that was what's done with 11N and 11AC and Wi-Fi 4, Wi-Fi 8 to really increase the throughput and increase the data rates and support new applications. But after a point, there was a bit of a saturation in the experience data rate because of interference, and that was with 11AX. That was changed. It was greatly improved with the introduction of OFDMA, uplink, multi-user MIMO, and special reuse. And that way, the experience data rate in dense scenarios greatly improved. And now, in the latest standard amendment that was released, we are introducing more focus on not only increasing further the data rates, but also allowing low latency through multi-link operation. In there, the idea is that an IP multi-link device can actually connect over different links. Let's say one link in 2.4 gigahertz, one link in 5, and maybe one link in 6. And that can be used to, for example, aggregate throughput, but it can also be used to lower the latency and access the channel faster. So it really brings a lot of benefits for this latest release. And as of this moment, we just started the standardization process of 11BN, which will be the basis for Wi-Fi 8. And in this case, we are going to focus on ultra-high reliability. Now, in parallel to that, there has actually been also developments to study use cases and scenarios for AI to be part of standardization. And in that area, there is an AI ML task interest group and standing committee being created. And they have been working on this topic since the middle of 2022 to really see how we can identify potential use cases for AI in communications. So now going a little bit into the questions of the panel. So if I would leave you with one key message, I would say, I think the main question is whether we need to put open source and AI into standardization. But from my view, I think the question is, do we really need that? Or rather, we just need to focus on providing interfaces for open source and AI to actually use the tools that standardization provides. And I think this would be, in my opinion, a more beneficial use of AI and open source. So let's go a little bit into each of the questions and a bit of the insights that I would like to provide. So first, thinking a lot about conventional standardizations versus basically room for chaos. So in this case, I think it's important to define what do we mean with chaos and what do we mean with standardizations? And I think in my view, chaos basically has to do with the implementation-dependent solutions to bring forward new technologies. But if you think a lot about what standards do, then it's basically we create specifications to also support new technology. So in that sense, it's a bit aligned, so there not necessarily be some sort of misalignment there. But I think what is key about standardization is that we really strive for creating a minimum set of rules and protocols to provide interoperability. And this interoperability is fundamental to be able to use technology all over the world. That's why no matter which vendor is your device, no matter who is the vendor of the access point, we really don't check who is the manufacturer of an access point. We arrive to a room, we turn on our Wi-Fi, and it works. We don't know if it's Wi-Fi 5, 4, 6, 7. We don't know anything about the environment. We just know we turn it on, and it works. And this is the powerful aspect of interoperability. And we really need to be careful to protect that. And therefore, I believe standards are really needed for maintaining this interoperability. Now, thinking a little bit about the role of AI in wireless standards. Well, I think I agree a little bit with Erik and what he was said. Essentially, the point is, I think AI can do great things, but let's say it can be a bit brittle. And what I mean by that is that you can have amazing performance, but there are no guarantees. So sometimes AI can really do a poor job because if it has not been trained well, it has encountered an unseen scenario, and things can really go bad. Or it basically may not have enough robustness, or it might be very costly. So I think it's a good tool to be used for unsolved problems that are too complex, for which we essentially don't have good solutions nowadays. However, for well-defined problems that are well optimized, that we already have been, going over them and optimizing over the past decades, we really don't need AI there. I don't think it would bring a great benefit, and it would be too costly. Now, thinking a little bit about open source, okay, is it an opportunity? Is it a bit of threat? And I believe it's a little bit of both. I think it's an opportunity because it can bring new ideas, but I think more than the new technical ideas, the important thing that open source can bring is really assessing key use cases, assessing and evaluating use cases that can have market value potential, so that we know where it could be the actual market value added for new technology. And I think this could be really a way in which open source can help the whole community of wireless networks. Now, in terms of risk, I think we need to be a bit careful here because, as I mentioned before, interoperability is key. So if we have different organizations that do open source work and you provide different devices and in different deployments, all open source, but they don't cooperate with each other. So that you start more and more solutions that basically cannot operate in existing networks and cannot operate with each other. If we lose that interoperability, we basically lose the whole value that we have with Wi-Fi networks. And on the other side, what is even, I would say, a bit more risky is that if we have open source solutions that do not follow regulations, they are not certified and maybe not follow regulations, then we can even have issues that nobody can access the unlicensed spectrum because of sheer amount of interference. So finally, thinking a little bit about how can open source and AI give us benefits to the end user, I think a little bit like I said before, I think it would be relevant for complex unsolved problems, for example, resource allocation or cross-layer optimization. But I think the key value of AI in open source is really to provide new use cases that have market value potential. Okay. Thank you very much.
Thank you, Daniel. And then I open up for Sofie Pollin.
Thank you. So, for answering the questions, I will take the chaotic approach and not the ordered approach. I will not follow the questions in order. Sorry, Ozge. But I think you like a bit of an other voice anyway and approach in your panel. Okay, so first I was thinking about standards. Do we need standards? And then yesterday I was at Nokia and I heard a presentation about their 4G on the moon. So they put 4G on the moon, and then I was thinking, but why did they put 4G? And then I thought, of course they put 4G. It's long-term evolution. So for a long-term deployment, you need a long-term evolving standard, right? And you know, on Earth, so now they have the long-term evolution standard, and here on Earth, no standard is long-term. We keep producing new standards. This is an icon that you, when you Google standardization, is the first one you find. Here they're at release 15. I guess now we are already much further than that, even if we only think about 3GPP. So then I was thinking, could we come up with a standardization approach that allows evolution truly? And if you think about evolution, then we always think we need to build the strongest standard, right? 1 gigabit per second, 10 gigabit per second, 100 gigabit per second. But if you go back to your history books, then you see that Darwin actually said that it's not the strongest of the species that survives, even though the most intelligent one or the one with the most AI, but is the one that is most adaptable to change, right? Okay, so now we had 3GPP and Wi-Fi, so I think it's also time to bring O-RAN to the table. So O-RAN was also very popular here in many of the European research projects, probably also in many papers. I did not do the survey on that. So I'm not going to explain O-RAN in a lot of details because most of you are probably very familiar with that already. But basically what O-RAN does is it puts a lot of the functionalities in containers that run in a cloud, an edge cloud, a regional cloud, wherever you put a cloud, it doesn't matter. So you have a lot of functions, DO functions, CO functions, RU functions that run on different clouds. So you could argue if it's going to be efficient and energy efficient if you run everything in software on the cloud, that's another thing. So on the partitioning of the data plane, specifically according to O-RAN, I guess we can discuss if that was the best way to do it. But what is really interesting in O-RAN is the fact that you have these RICs, and you have multiple RICs. You have the near real-time RIC, the non-real-time RIC, and RIC stands for an intelligent controller. And the RIC has hooks to all these different partitions of the O-RAN physical layer. So the RIC can control CO functions, DU functions, maybe even RU functions. So it's something that could allow us finally to do some cross-layer optimization. So O-RAN opens the radio access network. It makes interfaces that are sometimes a bit rigid also, like if you want to do something really crazy, sometimes you're limited by the interfaces, but still it's a first step towards openness, which is not open source, and creativity in the control plane. So let's have a look into this control plane a bit in more details. So here you see all different control objectives, and you see that in O-RAN you have different types of apps. You have R apps, X apps, and also recently has been proposed the concept of D apps, which is not an official O-RAN app, but it is interesting because these D apps, they run actually close to the DU. They get access to all this physical layer information, channel state information, IQ samples, and maybe they can do really intelligent things there. And here also you see in O-RAN you have intelligent control at different timescales, at different layers. So if these RICs share information properly, we could do real cross-layer evolution of our networks, right? Okay, so let's look into some examples of some possible D apps and how intelligent they should be and could be. So the first thing that I will present to you is a kind of D app, you could call it, that takes channel state information represented by a channel matrix H, puts into a neural network and gives position information. And here you see the measurement setup that we use to collect the data set, and you see the result of the positioning neural network, and you see that it is super accurate. So is this now real AI? Is this now reasoning or compressing a large data set? In my view, AI here is just used as a compression tool. And we take a lot of measurements, and the performance of our network depends only on the quality of our labeling. The learning itself is actually just a compression algorithm, right? Okay, so the real challenge, I guess, here, if we want to do AI, is to collect data, label it properly, and make it work also in unseen scenarios. And so I guess the AI, we should focus more on learning for unseen data. We have seen many demos with boxes where we can emulate channels and get really good performance improvements, bit error rates that are better than traditional models if we use AI. But in the end, these are AI algorithms working on a compressed version of the channel models that were seen, not unseen. So we work on unseen scenarios, and I think it would also be cool if we could do really online reinforcement learning and make systems that have really this adaptation control loop. So for that, I'm going to show some screenshots from a video we had also here down. So here you see our self-free massive MIMO testbed. So we put antennas in the corridor and in the lab, and we have some students running around. And here you see this, in the upper plot, the signal-to-noise ratio gets with one algorithm in the RIC, an algorithm selecting only one of the sub-arrays. And then you have the performance if you have another algorithm that takes multiple sub-arrays. We call it self-free. But the main message I want to bring you here is, I guess all of you in the room could come up with a better algorithm that has perfect SNR, right? And even a reinforcement learning agent could do that easily. So for me, the strength of the open source community is we can create data sets, label data sets for training our AI models, and we can even create testbeds on software-defined radios that are fast enough if we accelerate them on FPGA to do this online reinforcement learning and come up with algorithms to control various parameters of the physical layer. So one more slide to conclude. So we need open source and AI for long-term evolving networks because they're really a good tool to generate data by open or open source or whatever easily accessible deployment, so we can train and evolve our models on real data. The key is the labeling, how to label, to describe how the measurement was done, what is in the data. So maybe we should actually even start to standardize labeling. We need to focus more on online learning, reinforcement learning, learning unseen scenarios. I think ORAN is cool because it's the first step to open boxes, but I think in the future also the ORAN interfaces should probably evolve. And I think the really interesting thing, and it's the last bullet, and I will conclude with that, is that it would be really nice if we could make RICs run intelligent controllers that go beyond cellular networks. That can include Wi-Fi, physical layers, non-terrestrial networks, radar, and create really cooperating networks in the future. Thank you very much.
Thank you, Sofie. And I'll leave the floor to Amir, Aminifar.
So let's see if this one works. It's easy. Does it work? Yeah, it works. Okay. Maybe that's easier for me. Can you? All right. Good morning, and thanks very much for inviting me here. My name is Amir, Aminifar, as Ozge said. And I'm an assistant professor in machine learning at Lund University. So just let's see, quick disclaimer that I'm actually not a 6G person, neither am I a standardization person. I know a few things about AI, and I try to share my perspective here. So we were asked to answer this question, as you saw before. So the first question was on, is it good to have chaos in order, or maybe order in chaos, and or should we continue with conventional standardization techniques for 6G also? And I think that this is a very good question, and from a technical point of view, considering all the trade-offs between efficiency and flexibility, for example, you will have some kind of a truth there in terms of technical aspects, right? And but I think that this is important to not have this discussion in a vacuum, and I think it's important to consider the context and in some sense to look at the incentive of the players involved, including companies who are in wireless communication, companies who use wireless communication, end user, governments, regulators, etc., etc. I think this becomes a complex system, and we have to look at the dynamics of the complex system. And basically, you can model the complex system. And the premise of this kind of panel was that if you have this kind of chaos in order, the smaller players can provide, let's say, value to the governments, users, and other companies, at least. And I think it's important to consider, as I said before, the context when we are analyzing and answering this question, and we should see what kind of a game we are playing here, and is this a cooperative game or is a non-cooperative game? Is there an equilibrium here? Maybe we are already in an equilibrium, or what should we do to be in an equilibrium? And regarding the second question, which is better within my research interest, I think that actually anything that can be optimized can be learned and has some kind of a pattern will be optimized by AI sooner or later. And this includes spectrum allocation, sharing, energy efficiency, throughput, latency, and so on and so forth. But I think there are also less obvious cases that AI can contribute to. And all of you have seen, I think, ChatGPT, right? It's a generative AI approaches. And I think that it's possible that you have automatic protocol generation also. And we have seen, let's say, even the simple cases that you might think is trivial, like matrix multiplication, have been optimized by reinforcement learning by Google, for example, which is, I guess the same will happen for the protocols in communication domain. So regarding if open source is an opportunity or a threat for our industry and entrepreneurs, I think if you look at this view that open source with open source, basically smaller players can create value for other players in the game. But I think that you could look also the other way around. Maybe this is not only the smaller players that can provide value. Maybe the bigger ones also can provide value. And the question is that could this be, let's say, could open source be actually also an opportunity for the bigger players? I mean, one example is that in the IT domain, it's very common in the US, for example, you can invest to basically develop something yourself, or you can have others developing and then buy the best, right? That's what happens in the IT domain, and I think could be also similar if we have open source in the communication domain. And about the last question, if we can provide benefits for the end users, AI and open source, I think they will have benefits for the end users, but of course there is also a dark side to AI, and at least AI and maybe also open source. And one of the cases, for example, is the carbon footprint of the AI. And a few years back, actually, guys at Alphabet or Google, they wrote this paper that the carbon footprint of AI or machine learning is plateauing. And I mean, it goes without saying that when you write this paper, you have been provoked a little bit, right? And within the same exact paper, they wrote, they gave numbers that training one model, GPT-3, which is closely related to ChatGPT, consumes as much energy as one town for a day. And that's nothing negligible, let's say. So maybe a main question here is that would we gain more than we lose with AI? And is there anything that we should consider basically to be able to use basically AI in a way that we gain at the end? And of course, this is not the only thing. It came up in the discussions that there are security, privacy, safety issues with AI robustness, and I think they are all things that has to be considered when you use AI in communication domain. So I actually don't have, as you saw, a lot of answers, more questions. I try to contribute to the panel, and I'm very much looking forward to listening in and discussing with you about these topics. Thank you very much.
Thank you, Amir.
Good morning, everyone. I'm Emine Ozge Yildirim Rankart. I'm a PhD researcher at KU Leuven at the law faculty. So I will be bringing a different perspective than everyone else today, because I think it's more of a bus-killer part where I will tell you that you might not be able to do certain things even though they might sound so cool. So it's a bit more ethics and fundamental rights part. When I was asked to speak at this panel, I immediately thought of digital divide from prior technologies, and I wanted to look into certain fundamental rights and principles to see their relation with the digital divide in light of 6G, AI, and possibly open source. For example, some of these rights are right to access information without interference. This is crucial for education, economic opportunities, and personal development. This is also an important right for meaningful participation in public discourse. Another right relevant to right to access information is right to internet access, even though it's not a universally accepted right explicitly. This is also a crucial tool of accessing information without interference from public or private actors. So, for example, unfair resource allocation might create barriers to right to internet access. And also in relation to this, the third fundamental right I am going to look into is the right to non-discrimination and principle of fairness. And here what I mean is equitable access to digital opportunities is essential to prevent discrimination and ensure that marginalized communities are not left behind. So in light of this, I would like to ask, do we believe that 6G will actually bridge the digital divide created by prior technologies as well as societal inequalities as existing for decades or centuries, or will it actually amplify the divide? I think when I look into this, the answer is not straightforward from the ethics and fundamental rights point of view. So for that reason, I wanted to briefly identify some benefits and challenges concerning the digital divide in light of the question I was asked. So if we first start with standardization, conventional standardization versus more chaos, more flexible approach. So here, we know with the standardization, there are some benefits such as ensuring interoperability and reliability. This is crucial for consistent and equitable access to information. Also, establishing consistent protocols and helping to prevent digital fragmentation and ensuring that all users benefit from advanced technology infrastructure is also a benefit of standardization. But there is also the challenge of slow adoption of new technologies, and they can delay the deployment of cutting-edge solutions to underserved communities. And another aspect is dominance by large industry players may perpetuate existing disparities. So both of these challenges can create problems in terms of access rights and fairness and right to non-discrimination. But when it comes to the flexible approach, it also has some benefits, including rapidly addressing unique community needs, promoting inclusivity, and offering localized solutions. So this could enhance access. Also, it enables quick adaptation and deployment of technologies to meet the specific demands of underserved areas. So this could also foster the right to non-discrimination by providing tailored solutions to these areas, these people. But there is also, I think this was also mentioned before, but there's also the problem of lack of standardization. And and this can lead to interoperability issues and fragmented networks, and this can actually complicate seamless access to information and services. And another aspect of having fragmented networks is that this may disproportionately affect marginalized population and limiting their access to essential information and services, also potentially increasing digital exclusion. So in that sense, I would like to give a humble recommendation. I think the better approach is a hybrid approach, having the reliability and fairness of standardization with the innovation and inclusivity of flexible approaches to not hinder these fundamental rights. Regarding the second questions, role of artificial intelligence in wireless standards. So we know that with AI, it has several benefits. I'm only gonna mention a few. For example, it can enhance network efficiency and performance and optimize resource allocation, and it might broaden access in this way, and it might support unhindered access. But it also adapts dynamically to user needs, and this can, again, help underserved communities by promoting them better access, broader access, and enhancing fairness. But there is also the problem of biases in AI systems and potential amplification of inequalities if AI is not managed correctly. So this could both lead to unfair resource allocation and discrimination. And also we need to consider the privacy concerns and accountability issues in AI systems because this may also undermine trust and secure use of AI-driven solutions. So it's, in that sense, I think it's probably better to use robust ethical guidelines and regulatory frameworks if AI is going to be utilized in these wireless standards. And this can help, again, with protecting fundamental rights unhinderedly. But of course, when I was also surprised to see that regulation was the least mentioned term when looking at the statistics of the papers, but I think that is to be expected. And when it comes to open source opportunity, is it an opportunity or a threat? I think, again, the answer is not straightforward because with open source, especially for innovators, and innovation, this could lower barriers for entry, so that could foster innovation and collaboration. So this is good for enhancing access. This can also encourage diverse solutions and rapid development, and this could also, again, promote inclusivity and broader internet access. And also, possibly, it might provide transparency, enhance security, and trust. And again, this would enhance fairness and non-discrimination efforts. But there's also the problem of potential quality and support issues, and this may threaten the reliability of information and internet access. And when it comes to the industry, there is also the benefit of deriving competition when open source is implemented. So this might lead to better and more affordable technologies. And it enables rapid adaptation to technological advancements as well. So again, this can enhance internet access in equitable ways. But there is also the challenge of risk of reduced revenue for traditional players. So this could affect the sustainability of certain services, again, affecting access. Also, ensuring quality and security in open source solutions is crucial to maintain trust and prevent discrimination because this might also pose challenges. So in that sense, again, I recommend the balanced approach where open source is supported by robust quality control. And lastly, regarding the benefit for end users if AI and open source are implemented in 6G, I think I already talked about this main benefit is actually lowering costs and enhancing accessibility and supporting universal service obligations. So this might democratize access to advanced technologies. But there is also the risk of digital fragmentation without proper standardization. and also potential exclusion if solutions are not universally applicable. That means that, again, access can be hindered. So in that sense, it is also important to ensure privacy, security, and trust and equitable access. And these measures will prevent discrimination and ensure that technological advancements benefit all users fairly. To conclude, these are all theoretical approaches from a research perspective, so this doesn't have to be the reality, but I would like to ask you as more technical experts, how can we best balance standardization and innovation to ensure that 6G technology fosters equity, inclusivity, and security for everyone, regardless of where they live or who they are? Thank you so much.
So thank you, everyone in the panel. A broad spectrum of views on these topics, and that was the whole idea by such a broad range of competence in the panel. We have everything from, let's say, those working with standards today, to those who do research on new interesting things in wireless communication, to those who work with AI, and also those who take care of us and make sure that we don't do anything stupid along the way. One thing that has come up here is that I think of is that we don't have to do much different in the standardization, but I've also heard, maybe not here, but in other contexts during this conference, that we don't even need a standard. I mean, with an AI, we have the regulation, and we give the AI the regulation and the resources and say, communicate as best you can and solve it. So I guess Erik don't agree on that. So I think maybe we start here and just ask, how do you see that, letting an AI loose totally to figure out everything, just saying, here are the rules you have to follow, here are the resources. And we can start here with Emine.
Sure. Well, since I'm not a technical expert, I don't know if I can answer that question, but I'm a big fan of open source, to be honest, but of course I cannot say that all solutions would be much better than standardization, for example, if there is more flexibility. So in that sense, I think I will leave the room to technical experts first to hear their opinions.
Right, I think that it came up that there are some challenges with such a decision, right? In terms of robustness, fairness, maybe, and I agree. And there are, let's say, recent studies and research in that domain, including ourselves. We are working on trying to provide more trust into the decisions made by the AI. So, for example, if you let's say have a male, I mean, a typical case is that if you have a male patient and a female patient, then the decisions, or let's say like black patient and a white patient. That was a case in the US, for example, where basically they saw that a lot of resources are going into the white patients rather than the same situation in the black patients. They could get much less resources in the US, and but there are actually techniques So the challenge basically is that for the very strong hard guarantees for serious neural networks, we are still far from that. So we can only handle small neural networks right now, no transformers, no LLMs. So it's a complex task. That's what I want to say. Yeah.
I think we should also, I don't think we should let AI just figure it out. I think we should be careful. I think when we train a model, for instance, from a certain SNR range from 0 to 20 dB, we should test, does it then work at 21? How much performance deviation do we have? And also get the boundary conditions, like if we then work at 25 dB, your AI model is not trustable. So I think we need more research on that and set limitations on when the AI model works and when it does not work, because for sure it will not work in all scenarios. And I think we also need much more work on combining AI with models and make them work together in a way that we can figure out when is AI better than the model, or helping the model, or calibrating the model, and when should we fall back on the model because AI is just not trained on that signal-to-noise ratio, to make it simple.
So I find it interesting that somehow the side of the panel advocating for AI is not very convinced. So I'm wondering what should I be saying, because I think might not be the best approach to having an AI just figuring things out by itself. But also one should be a little bit open, no? And not necessarily going to advocate for AI, but I think there's a fundamental issue that we are not there yet. So there is not enough computing power, and there is not a unifying framework for AI to work in wireless communication to do everything. That just doesn't exist. Perhaps in the future it might, but it doesn't exist, and it doesn't look like we are heading that way. So I see that a difficulty of actually getting to the technology level to enable that. And second of all, I feel that might not be working as good as we think, you know? Like, who's going to provide those services? And maybe you will have huge companies having the best AI, but if you have, let's say, smaller companies with different AI, can they actually participate? Or if it's going to be like, okay, a huge open source, a huge standard, everybody can have access to it. Okay, so how is it going to be funded if it's then free for all? And who's going to pay for all that huge computing power? So I very much believe in standardization still. And I think in standardization, we can actually already, as of now, implement AI, because AI can basically use the features that already exist. And you can improve the system, you can enable new ways of cross-layer operation and going optimization, while still keeping to the bounds of the standard, so you still guarantee interoperability and following regulations. So at that point, let's first try to see if AI can do things much better with what we have, and then we can see, okay, maybe at some points, actually, it needs a little bit of more room to play. And then, even then, I think before having this end-to-end AI, we can, I see it, for example, allow a greenfield AI somehow operation where you leave it for a little bit of time, okay, do what you want within that bound, and then we see what happens. So let's say I very much believe in standardization so far still, and we still will need it for the future.
First of all, just because you worked in standardization 20 years does not necessarily mean you love it. You could hate it as well. But I don't really see the conflict here. I mean, between open source and AI on one hand and standardization on the other hand. I mean, for quite a long time, I may be able to buy the open source code for entire 4G network as open source, get it for open source. But it would be rather difficult to have a kind of open source code for an LTE network if there were no LTE standard. So I mean, that is kind of open sourcing that implements the standard. So I don't see that kind of conflict really. And on AI, people use the term AI as some kind of magical thing. I mean, it's a thing that can answer any kind of question. And of course, if I have something that can answer any kind of questions, I don't need any standardization things, because but I mean, that's based on the assumption it can answer anything, and I don't think it can do that at all. So to me, AI, and I guess when people talk about AI, they actually mean a deep neural network in practice. And that's a technology in some sense like any other technology. And of course, we will use it where it fits. And I happen to think that it fits probably better in more in the kind of higher layer problems where we, anyway, as I said, I mean, today are relying on our gut feeling compared to the many of the physical layer aspects where we have a very good model of the world, or at least a good model of the world. We know what we want to achieve, and we can actually derive how do you achieve that with that model in quite an optimal way. I mean, in that case, AI cannot do better. So, I mean, to me, once again, I mean, AI, there will be a standard and or specification, and AI will be an important tool in that when we're developing that standard. And that thing, but I don't see the conflict. Thank you.
Thank you. Well, I think it's good to see that there's some sort of there's enthusiasm for these new technologies, AI and so on, but there is at the same time a decent level of let's be careful. Sorry? Yeah, okay, please.
Sorry to interrupt, but I had to ask this. You group open and AI on the one side and standardization on the other side. But I want to ask, do you think necessarily AI is open? So how does AI make a decision? Does that, let's say, correspond to the principles of openness completely? We have explainability, transparency challenges in AI. So why do we think AI and open goes together?
I myself don't necessarily see that they are put next to each other as I see it, two different interesting approaches to things, but they're not necessarily the same thing. I don't know, maybe the panel has a different view on it. No.
No, I fully agree with you when it's rather a little bit opposite that AI, whether it's open or not is one thing, but I mean, do anyone know how AI solves the problem? Sometimes I ask people, because I think it's an interesting question. I mean, in some, even physical layer, like I'm a physical layer person, you get kind of, actually get good results. And I ask you, can you explain why you get the good results? And the answer you get is typically, I mean, you get good results because it's AI. I think it would be interesting to more in a more deep understanding why you get the gains, because then maybe you can actually combine the AI solution with our human intelligence and do something that is even better.
Maybe if I would say something, I think, yes, I agree that the AI is typically a black box. We don't know how it works. We just know inputs, outputs, and what it does. But I think the combination of open source and AI is there because basically when you have an open source software development kit that you want to optimize, you can use AI tools as well and try different things and optimize together. And I think maybe that's why it goes together rather than thinking that what AI does is actually open and we can understand it, because by definition we really cannot.
And I fully agree with your comment. It's good that you say it to make it clear. What I personally think is that we should make the data more open and use open source to create open data sets so everybody knows what AI is trained on. That's probably much easier than trying to understand what the AI really learns. I think it's just a data compression, and then if you know your data, you know what the capabilities of the AI model are, more or less.
Yeah, I also agree in general, let's say, and I think there are some indications that AI, how it works, let's say, and but I mean, I can interpret open differently here, in fact, because in fact, I was at EPFL before I come to Sweden, and I had a student who was collaborating with ETH Zurich, and at the time there was a new model which came out, transformers based, and an interesting thing that we heard from this student was that the amount of money that you have to buy the GPUs to train this model is so much that the whole ETH Zurich budget is not cutting it, you know. So in that sense, is kind of, yeah, not so open for everybody. At least, yeah, they can open some versions, but not everything that can be done with it.
Well, I think, as you mentioned, open and AI doesn't have to be the same thing. They might have the merged area where you have open AI, but not like the company. But I'm thinking is that where I think for example, in my presentation, I explicitly actually looked into using open source AI. Because I think that will be more beneficial and more decentralization will be more beneficial in that sense. But when we were looking into this, it's more like chaos in the sense that use of AI, but also open source together and separately. So I don't know. I mean, not a very technical answer, of course, but yeah.
So thank you for these interesting discussions. I have a question which is more on the practical side of, I mean, if we go from standard to AI-based kind of solutions, this is on, I mean, we are using now networks for more and more critical, as it's a critical infrastructure, we want to have dependability. And how is it with regards to reliability? If I have a standard, I have an agreed set, I can pre-test, I have a repeatable setup. And if something doesn't go right, who's then, what's the liability? Is it the one who implemented the AI model, or is it the operator who trained it with the wrong operational data? Or how is the liability if, for something that is done purely self-organizing as AI?
I think that question might be pointed towards you, Emine. It sounds like a question for you, or you can start at least.
Yeah, I don't think there is, like the regulations are really answering that right now. The liability issues, well, to be honest, I don't have an answer to that, because the thing is, with the liability issue, of course, there are some regulations. We are trying to make, you know, new regulations, AI Act and other things, but there is not a simple answer, and we also need to see these things in practice, because all of these things are very abstract at the moment. So we need to see it happening in practice, and like what's done in that situation. Let's say assessing the facts. But right now everything is very up in the air. So yeah.
I can double that, actually, second that. I think this is $1 million question. It has been there for autonomous driving systems. For example, if you have a car driving and then you are going to crash for sure, but one side of the street is let's say an old person, the other is a mother with a baby. So which one would you take? So it becomes, and which one would you take, and who is responsible for that decision? I think that there is no easy answer to that, let's say.
So there's this whole document written by the Commission on trustworthiness in AI, and it's defined very broadly, but you have also this technical trustworthiness, I think, which is knowing when your model will stop working and detect that your model is not working anymore, so that you can fall back to a non-AI based method. I guess indeed we need to think more about how we can detect such things to have more, if you want to call it trustworthy, reliable, whatever, AI solution.
I find it interesting, the word reliability, and I feel maybe our first thing that one needs to do is define it. So what do we mean with reliability? So for example, if we talk about physical communication, we have very specific KPIs for that, right? We say we mean packet error rate at a particular level, and we know what we get when we have a communication system. We know, okay, if we are above this SNR, we know, and we have a particular EVM, we know we're going to have a particular packet error rate, so we can predict and account for that. And that's the thing with AI, that unfortunately cannot provide that, right? AI can work very well, and typically when we want to know the performance of AI, it's always training set, testing set, and then you always test on your testing set, and okay, this is reliability I have with this on-scene data. But then how does it generalize in the world? We cannot give any guarantees. So I think in a way, this is the point, that there is no reliability that we can accurately measure the way that we could do, for example, for 5 communications. At the same time, I think I would have to say, you know, for example, in 5 communications, we have this very well-defined framework. As I said, you have the target, if you get this SNR, you can get the packet error rate. But do you get the SNR? I mean, that depends on the channel, that depends on the congestion, that for example, on licensed bands, depends if there are interference and other technologies. So there is also a little bit of unreliability there that we really don't know if we are going to get the SNR that we need to actually guarantee the packet error rate that we're after. So in that way, being a little bit fair to AI, it's not like we have extremely highly reliable systems yet. At least in unlicensed band, maybe licensed band is a little bit different. What do you think, Erik?
I still feel that we are some kind of seeing AI as something kind of magic, a very specific thing, very hard border. This is AI, this is not AI. I mean, in the end, I guess the AI is this small chip from NVIDIA or Qualcomm that someone had put some stuff in. And we have a lot of chips in our base stations that someone had put some stuff in. And I guess if those base stations broke down, we are responsible. So I still kind of, we talk about AI, but no one really seems to understand exactly what it is. And it seems to me that it's very difficult to come up with kind of specific rules, etc. for AI if we don't define what do we mean by it. And because I still, I mean, it's no fundamental magic. It's kind of a way of, in the end, it's a way of connecting a small perceptrons together and train them in a certain way by a certain tool. And we have enormous amount of them. And it works very well in many cases. But it's no magics. And then I fully agree. I mean, as we have no, we typically don't really know why we are programmed in a certain way, because we've been training with some kind of algorithm. Then we are, of course, feel less certain that will work in all cases. So there is a reliability problem.
See, we have a microphone. Yeah.
Thank you very much for your insights. I have a couple of questions about open source. So it would be really useful to listen to your views about some specific examples where open source can play a role in 6G. And the related question is the following. Do you expect that open source will have the same success as it had for the IT world in the domain of the telecom? Can it fly if the Nokias and the Ericssons and the operators are not really involved in such kind of activities?
I think open source can do a lot, and we see that here we have open Wi-Fi as a RSLTE, so we can do a lot, but it's all a it's really difficult. Like here we're spoiled with very good networks, very good hardware accelerators, and it's really the networks are good, I think. I'm not an expert, Erik knows better, but I would think that you need really this hardware acceleration and really good system design to have really high capacity, very performant network. And that's something that will be difficult for open source community. But we have a lot of regions, I think, in the world that are underserved, that are not yet served, niche applications. So there's probably a role to play there for open source community where they don't have good networks yet. So any network, basically, even a few dB worse than what we're used to, can have a role.
I think just a little bit, give a little bit of insights. What I know about open source Wi-Fi implementations is actually kind of already there. So there are 2 main groups, open source groups for Wi-Fi that I'm aware of, and one is with Telecom Infra Project, and they have a very large community, over 100 involved institutions. You have companies, you have universities, research labs, so it's a huge community. And in there, actually, you have a software development kit full of APIs that people can program, and all the members can program and play with it and really come up with new technology. And at the same time, you have actually APs that are enterprise-grade hardware that are regularly tested, and they're actually complying with current standardization. So I feel this way of doing open source not only already exists, but it might actually benefit a lot because it can actually reduce cost of R&D for a lot of companies. And in fact, the same companies that do the standard are actually also, not all, but many of them are actually part of this open Wi-Fi. And I think it really can benefit a lot in related to what I said earlier, to really identifying what are the use cases that would have market value. Because this is the thing, it's not really that we are needing new ideas. There are heaps of ideas everywhere, millions and millions of papers, and millions of different presentations and insights. What we need to know is what is going to have real value at the end. And I think there are already, let's say, open source communities doing that. And it's actually another open source community. Actually, they have a demo here with IMEC. There's 2 nice demos about open Wi-Fi, and they are already also having the FPGA with the Wi-Fi 4 running. I think they're looking to upgrade, and they're doing very interesting results in roaming and so on. So there is actually already development going on in that way. In my view, the important thing is that we really need to make sure we keep interoperability and follow regulations. So far so good, but let's see.
Yeah, I mean, I must admit, I know very little about open source. I mean, if a large group of people can come, maybe they'll be able to come together and kind of build a 5G, all the software you need for a 5G base station. And if that would have the same functionality and the same performance as the equipment based by the big manufacturers, of course, that could be an interesting thing. It could be also an interesting problem. As I don't know very much about how it works. I mean, for example, I don't know how the IPR situation would work in that situation. I mean, I know that the IPR situation in our business is a big mess already. So I don't know what happened in that case. I mean, if it were even possible to have for operator to operate such a base station or such a network.
Yeah, thank you. I have a question regarding AI native design for 6G. And usually we hear in this design distributed AI. I'd like to have your opinion on how stable is distributed AI is for telco designers to take it in the native design of future, telco architecture. And then, of course, we will think about the standardization open source. But first, what is your opinion on this distributed AI in the native AI design for telco architecture and 6G?
Could you elaborate? What do you mean more exactly when you say AI native? Because the word is used very often, and I never really get an answer what people mean by it.
Yeah. When you read like the AI in 6G, you have like 2 levels. Either you have 6G in the automation of network management, and then you have AI on the physical layer to better manage the resource allocation. So the native part is, I would say, more in this field layer, and it comes as a distributed AI architecture. So how stable is AI models and AI solutions for this type of specific need from telecommunication?
So it's a difficult question to answer. So if we talk about AI for the physical layer, we've shown many demos where we had a better bit rate as function from SNR. So I'm pretty so it is better than traditional models, but you have to be aware that it is only for this specific data sets for which it is trained and this specific channel model. So if you use that AI model on a very different channel, it will not work anymore, right? So I think the key will be in detecting when are we in the scenarios that fall within the region we are trained for, and we can use the AI model to give us better performance, or when were we just in unseen scenarios on data we did not train for and where our AI model will fail, and then we use more traditional methods. I think that's probably the more logical way to start using this. I don't know if it's an answer to your question, but...
First, I'll get a little bit surprised here, because I thought kind of the point with AI was that you should actually be able to handle unexpected situations. And now it feels like the AI will not be able to handle unexpected situations. This is about distributed models. I mean, I can understand what did in the 3D people was that they kind of identified 3 cases for AI in the first stage. It was beam management, positioning, and so-called CSI reporting. And both beam management and positioning was really kind of thing you can run it in the base station separate. But I mean, CSI reporting was really kind of, in essence, AI running, the AI model running distributed over device and network. And that becomes very complicated, because then you inherently start to specify how you should implement things, which goes against all kind of the specifications. The idea of specification, both for 3D people and overall, is to really specify the interfaces, and then you implement the way you want. So I mean, I think that's very difficult. Maybe it will happen sometime in the future, but it's really difficult to kind of agree on how you should do that.
Yeah, I can. I mean, I also miss a little bit of context, because distributed AI could mean different things, right? So we have the distributed learning in the machine learning domain, right? And that means that you have data from different sources, and they learn kind of collaboratively, and then they get a model that is hopefully better than if you do it alone. And another scenario could be after learning, right? When you have the models implemented, and then you want input from different places to make a decision. So I think depending on the situation, it really can be beneficial. Distributed learning is, or federated learning is being used these days, right? I mean, it's in Gboard and iOS 13 and so on and so forth. So.
If I would maybe say something quick. So I think I have two main points here. One, AI in the physical layer, I think we need more advances for that. I think the physical layer is pretty efficient in working really smoothly and predictable. AI can do something, but I would think there are much more interesting problems out there than improving the physical layer with AI in this moment or in the future, I would say the next 5 years or so. However, this idea of distributed AI, and I think if you have time, I would invite you to look the presentation by Nokia, because they have a really nice presentation about self-organizing networks and self-optimized networks using AI. And what they have done is essentially have AI agents of different parts of the network, not just the access network, but also the core network and the transport network. And there is basically a joint optimization of everything. And in those senses, I feel AI can be very, very powerful, because it's not about having, you know, a more efficient modulation that can give you 3 dB to get a little bit more packet at a rate. It's actually how do you enable a full service and enable a full experience, so that you have an event, you come, 1,000 people come. How do you actually make sure that all of them can communicate at the same time, send videos, send updates, access their Instagram and so on? And it's really not about improving small bits and pieces of the network, but giving this full performance. And I think in that part, doing distributed AI in that sense can actually bring a lot of benefit.
Hi. Yeah, thank you. My name is Mitch Zheng. I'm a consultant. I don't do real work. So, Sofie, you're safe. I won't ask questions about open source, but my question will be directly to Erik, Daniel, and also Amir. But Emine, you are not free here either. I think my question is actually that how are we going to use AI to help us build a better 6G systems, like the gentleman talking about reliable, and then you can cover the reliability, right? Because I think it all depends on how we ask a question. So if Emine say, well, AI, tell me what's the meaning of life, it will give you 42, right? It will give you an answer 42. But if Emine, you ask a question, say, okay, how do I build a wonderful RAN for 6G? If you ask a question like that and AI went to do all the search, come up with an answer, I can tell you I won't trust that, right? So I think, Daniel, you brought a very good question. How do we phrase the question, right? So when we ask AI, and then once you phrase it, then we can use Eric's knowledge about how can we fine-tune that and then eventually go to that. I don't believe AI is a magic box, right? So I mean, how you see this part. So the question is, how do we leverage the AI technology to help us build a wonderful 6G system? Thank you.
I'm uncertain if the question was a very complicated question or a very easy question. I mean, to me, I mean, as I said, to me, AI is a great technology. There are many great technologies out there, and we will just use it wherever we find a need, we find a use for it to enhance the performance. And as one thing, I don't think it's some kind of magical use. I mean, we will have experts that understand AI in detail, and they will understand where it fits and where it does not fit, and where it fits, it will be used to enhance our system. That's as simple my answer is. Maybe it was much too simple.
I think similar to what I mentioned before, we should use it to solve open problems that don't have a solution. And I think I gave a little bit of an example of this self-organizing network that you can use AI agents, and I think that's a great example of what is already being done now. So I don't know exactly what will be done in the future, but it's a great example to take us further. And I think the main point is, or I don't know, I wouldn't say the main points, but I would say there are two main things. Do we want to use AI to improve wireless communications or communication systems? Or do we want to improve the working of AI by using communication system as a leverage? Who is there for who? And it's both, actually. You can use the communication systems and change it a little bit to improve AI. For example, there's use cases in the IAML group where say, okay, we can actually make the transfer of learned learning insights from each AI model more efficient so they can transmit it faster throughout the network and that can improve. But then it's not AI for the communications, it's communications for AI, for example. Or you can use the AI to actually the other way around, like self-organizing networks. So I think the key point, if I would have a key insight, is we should use it for things that we just cannot do well now.
Yeah. And so one thing is, sometimes we seem to think it's AI or human intelligence, it's AI or standardization, but I think they should go together, right? I think we as humans, we should use AI to summarize documents, summarize papers, analyze papers, even it's about how we will use it to make a better run, but I don't think AI will make the 6G run. It will be us, the standardization, using AI tools as much as possible where relevant. Yeah.
Okay, I start with, I mean, when I have an AI course, let's say, I ask the students when you should use AI. And then they struggle a little bit. And then I show them a picture of a cat, and then I tell them that try to mathematically formulate what is a cat, you know, integral of e to the power of whatever, you know. And that actually is basically the main idea why you use AI. It's a complex problem. You cannot explicitly program. You learn based on samples you see, right? And this discussion that we have here actually, it came up also around maybe 30 years back. So Alan Kay, I don't know if you know him, he is a Turing Award winner, which is the highest recognition in the computer science domain. And he has a keynote on YouTube. I suggested to watch it. It's in Uppsala. And there is this discussion between traditional math and software programming and programming in general, algorithms. And there is, of course, the Dijkstra in the Netherlands, just here, and then the other side, Alan Kay, which is they are kind of rivals. And the question, I mean, at some point he points out that these algorithmic or software programs that we have here, they are actually they cannot be classified under the same framework. They are solving problems that are order of magnitudes larger, and they do it by covering all the cases. And I think the same applies here, you know, like you can go one step ahead, and what is AI versus simple programs and maths, yeah? At the end, they are the same, but, but they take it one level further than what we had before, let's say.
Let's rephrase that question, actually. Then. So then let's rephrase in a way that how can we leverage AI in 6G to the extent that 6G can actually be for the benefit of society, and maybe for the least fortunate member of the society. So maybe let's start from that point, more like a bit more top-down approach maybe, or the other way around, but yeah.
Okay, I think we have to thank the panelists. It's been a very interesting discussion, and I feel like we haven't even started yet, but we have run out of time. When you have fun, time goes fast. And how about a round of applause for the panelists? And I hope we continue this interesting and quite important discussion and take it with us into the future. Thank you, everyone.
Thank you to the moderator as well.